Okay, so I've rewritten our integral here using my other form of completing the square. So now basically I have a very similar integral right here, except for the fact that I'm subtracting this time. So I'm going to take my same approach, and I'm going to say let s this time equal u plus 1 over u. That means ds equals 1. This time it's going to be a minus 1 over u squared when I differentiate 1 over u. So now once again, my entire numerator becomes my ds, and the remainder I can plug in terms of s. So this becomes ds over s squared, minus 2 this time. So now there's a slight difference between this and what we did a minute ago with the trig substitution. The trig substitution in this case is assuming that I'm adding, but here I'm subtracting right here, so I have a little bit of a problem. Now when I'm doing this, at this point, one of the best things I can do is simply factor this out. So if I factor this out, I'm left with ds over s plus the square root of 2 times s minus the square root of 2. All I've done is taken this and factor it out. If I want to double check myself, s times s is s squared. Here I have positive square root of 2 times s. Here I have negative square root of 2 times s. Those two will cancel each other out. And if I have positive square root of 2 times negative square root of 2, that of course becomes my negative 2. So right now, I have this in terms of fractions, and partial fraction decomposition tells me I can separate this out into an integral over this denominator plus another one over this denominator. So if I have 1 over s plus the square root of 2 times s minus the square root of 2, partial fraction decomposition tells me I can write that as s plus a over s plus the square root of 2 plus b over s minus the square root of 2. So I'm going to multiply everything in here by both of these, and I'm left with 1 over here. When I multiply the s plus square root of 2, that will cancel out here, so I'm left with a times s minus root 2 plus b, and over here the s minus root 2 will cancel, so I'm left with s plus square root of 2. So now all I need to do is solve for a and b and get my proper coefficients. So I'll say let s equal, let's start with positive square root of 2. That means 1 equals, if I plug in positive square root of 2 minus square root of 2, that becomes 0, so my a term goes away. Positive square root of 2 plus another square root of 2 equals 2 square root of 2 times b. That means b just equals 1 over 2 square root of 2. Here I'll let s equal minus the square root of 2. So once again I have 1 negative square root of 2. This time will cancel out my b term. Negative root 2 minus another negative root 2 means I have negative 2 square root of 2a. That means that a equals minus 1 over 2 square roots of 2. So a and b are just the opposite sign of one another. So that means I can take this integral right here and break it up into these two pieces. So my a and my b So now why have I done this right here? Because I'm getting to a point where I can simply factor out these constants right here, and then I'll have 1 over a first degree polynomial, which we can easily integrate as a natural log. This happens to be the same one, and this a negative right here. So I'm going to just pull the entire constant out of these integrals. Here I have the positive one, so I'll do that first. And now I have the negative one. So all I've done is factor out my constant, and now I have the difference of these two integrals. This, of course, just integrates to the natural log.